Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No, we've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam, Praxis peeps, big shout out to you guys out there too. And especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hey, everybody. Welcome to Wednesday night math night. I am so excited to be back with you all. I was out last week because literally I had no voice. And 2 weeks ago, we had to end about a half an hour early because of my voice. We have been sick in our house. If you're in where you are, germs are going around. Welcome to the club. Whew! But we are on the mend. We are better. My voice seems like it's better, but we'll see. When I talk for a really long period of time, it seems to like have an issue. So we'll see where it goes tonight. But I am definitely glad to be back with you guys. Like Dr. A said, I'm Amy Sink. I am one of the math specialists here at the Learning Liaisons. And I absolutely love supporting teachers, future teachers, want to be teachers, college students, wherever you are at in your journey. I absolutely love supporting you because these tests are hard. And so I just enjoy helping you feel successful in mathematics because so many people just don't feel like they can do any math. And I like to break that mold and prove to you, yes, you can. So we are going to go over some problems tonight. They range from K through 12. Which is why I like to always do a get to know you question in the comment box so that I can get to know you, but it also helps guide my rabbit trail conversations. Hey, Marco, it's good to see you. So in the comment box, let me know where you're from, what test are you prepping for, and a get to know you question, do you like Broadway shows? As you can tell, I am wearing the Annie Kids show. Besides being an assistant principal, I also do theater productions. And so I am a choreographer for local theater productions. And that is one of my favorite things to do. And in fact, today at school, we had like club time or STEM time, if you will, or STEAM time. And I had a group of 20 kids that I got to just instill my love for theater and the arts into as well. So, do you love theater? If so, what is your favorite musical? My favorite, oh gosh, how to pick a favorite musical. That's a hard one. I would say my favorite musical, Matilda, Annie, Moana's a good one too. To watch, I like Wicked. I do not like Cats. If you have ever seen Cats, that is not my favorite musical at all. Choreography's good. There's just no storyline, and I need a story to keep me entertained. So, anyways, all that said, do you like Broadway musicals? If not, that's okay. It's not for everybody. My husband is definitely not a Broadway musical person, so it's just me, myself, and I in this house with Broadway musicals. Newsies is another good one. So with that said, let's go ahead and jump right into problem number 1, which is the volume problem. If you have been studying for the GK math test, you know this problem is like a classic for the GK. It is actually a 4th, 5th grade through 12th grade problem. This really could be assessed at any level. It's a little bit difficult for our elementary people, but technically it does fall within the standard guidelines. So technically it could be assessed on that. Marco, fellow theater lover, I love that. So problem number 1, let's read it together and then we will solve it together. So let me make the screen a little bigger while we read this problem. A farmer needs to compute the volume of his barn for storage purposes. The barn sits on a rectangular pad measuring 27 feet by 14 yards. It is 7.5 feet tall on 2 sides and is 8 yards tall from the base to the peak. What is the volume of the barn in square feet? So when we look at this problem, I always like to look at what is this problem asking me? It is asking me to find the volume of the barn in square feet. So the first thing I'm going to do is write out my volume formula for a prism, because this is really just a pentagonal prism. A prism is a shape that has 2 exact identical bases with rectangles going around it. So I see that my bases are here and here, because those are the 2 identical shapes with rectangles going around it. Don't be mistaken that this right here is the base. The way the problem is worded and the way the picture is drawn makes that seem like it is the base, and it is not. Don't confuse the ground with the base of a prism, okay? So that said, we know that volume of a prism, and that's just a little thicker than I want it, that volume of a prism equals area of the base times the height of the prism. Well, when we define height of a prism is defined as the distance between the 2 bases. Again, don't mistake the height of this barn for the height of the prism. They are 2 different things. So the people that wrote this problem that wanted to trick you want you to think that this is the height of the prism, which is going to be plugged in right here. There are 2 problems with that. Problem number 1, it's in yards, and the problem asked for the volume in square feet. Problem number 2, that's not actually the height of the prism, that's the height of the barn. The height of the prism is going to be 14 yards because that is the distance between the base or the two bases. So I could do volume equals blank times 14. However, 14 is also in yards. So if we're going to backtrack for my elementary and pre-K through 3 people, you got to know how to do conversions. GK people, on your reference sheet, you have the conversion for this. Everybody else, you need to know basic conversions. So 1 yard equals 3 feet. So 14 yards is going to equal 14 times 3 feet. Handy dandy calculator. 42 feet. Which means this right here should be 42 feet. Which means this is actually going to be a 42. Now, I have to find the area of the base, right? I find the area of the base. The area of the base is a pentagon. I don't keep formulas that I don't need in my head. What I do know is that this pentagon right here could be cut into a triangle and a rectangle. So I could find the area of the triangle, which is 1/2 base times height of the triangle. And I could find the area of the rectangle, which is length times width. And then I could do area of the triangle plus area of the rectangle equals area of the pentagon. That planning right there took me 10 seconds. But that planning is critical for your processing of this problem because this problem is so many steps that if you don't plan or write out a sketch of a plan like that, you are going to miss steps or forget what you just solved. Now, another problem, that 8 is in yards, so I need to convert it to feet. 8 yards is going to equal 24 feet because 8 times 3 is 24. So I know that the area of my rectangle is length times width. Here's my length. Which is 27 times width. What is the width of that rectangle going to be? Where is there a number that we haven't used yet? Ding, 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 ding. 7.5, which we know a rectangle has the same side, so that right there is also going to be 7.5. So I know that my width is going to be 7.5. So use my handy dandy calculator. 27 times 7.5 is 202.5. That is the area of my rectangle. I'm going to use my eraser and erase area of rectangle and replace it with 202.5. Filling stuff in as we go, right? Now, area of my triangle. Well, my triangle has a base of 27 because this 27 right here is also going to be the base right here, right? What is the height of my triangle going to be? Well, I'm going to use that 24 somehow, right? I know that the whole thing is 24. And if I take away the rectangle part, which is 7.5, what am I left with? 24 minus 7.5 is going to give me the height of my triangle. So 24 minus 7.5 is 16.5. So times 16.5. So now 1/2 times 16.5 times 27. And again, I'm going to use my calculator. You can have a calculator, that's fine. 222.75. Again, I'm going to erase area of triangle. I'm going to replace it with 222.75, which equals, add those two numbers together, 425.25. It disconnected. If you are new with us, welcome. Sometimes my iPad disconnects, and that's very frustrating sometimes. So let's go ahead and reconnect the iPad. I thought for sure we were golden. We were doing so good. All right. So now that we have the area, and I know that the screen isn't showing yet, now that we have the area of our base, which was a lot of steps as well, because we had to do the triangle and the rectangle, now I can go ahead and plug that into my volume formula and solve. There we go. Okay, so the area of my pentagon is 425.25. So now I can go ahead and plug that in here. 425.25 times 42 equals 17,860.5 feet, which is D. Now, I promise you, one of those answer choices is the answer for if you did all that work and you used the yards instead of feet. I guarantee you one of those answer choices would be that. So you have to be really careful that you always are paying attention to the units that it's asking for, but also what the problem is asking for. You have to pay attention to both. All right. That was a long, hefty problem. That took us like a really long time. If you are taking the JKT and you see this problem come up, I would skip it and move on. Not because you don't know how to do it, and not because it's hard, but because this is a timed test, and I need you to be able to solve that, what Dr. A says in our courses, if you're part of our courses, low-hanging fruit, which are the easier to reach problems. Even for proficient mathematicians, this problem takes a long time. So I would skip it and come back to it if you have time. I would not spend 15 minutes on this problem and waste that valuable time that you have on this problem that you could be doing other problems. All right. A pool company is building a rectangular pool with a deck that measures 8 feet wide all around. The pool will measure 12 feet long by 16 feet wide. If the deck costs $6.50 or $6.50 per square foot, how much will the deck cost? So in this kind of problem, I always encourage people to draw a picture. So we are building a rectangular pool with a deck. So here's my pool. And here's my deck. And what do we know about the pool? And what do we know about the deck? We know that the pool is 12 feet long by 16 feet long. We know that the deck costs this much per square foot. So I've already checked my units, and I realize that my pool measurement and my deck measurement and my deck cost membership are all in the same units. So I'm not going to have to worry about converting yards to feet or feet to inches or something like that. I can roll with what I have. So a 12 by 16 with an 8-foot deck all the way around. What does that mean? That means that this distance right here is 8 feet. This distance right here is 8 feet. This distance right here is 8 feet. And this distance right here is also 8 feet. That's what we know. And from there, I can begin to think about how to solve it. So there's two ways to do this. You can find the area of the big brown rectangle, which would be all of this, and then subtract out the pool. Or you can find the area of smaller rectangles. So you can do the area of this rectangle. You could do the area of this rectangle. And then you could do the area of this rectangle and the area of this rectangle, and then add them all together. Those are two very different ways to solve the problem, but are both ways that are going to get me to the right answer, right? So let's go ahead and talk about our plan. My plan is to find the area of the pool, find the area of the entire pool plus deck, subtract the pool from that, and then multiply by the cost. A lot of people, after doing so many steps, forget to multiply by that cost. They do the entire problem correct, and then they get the problem wrong because they forget that step. So let's go ahead and find the area of the pool. The area of the pool is going to be 12 times 16 because area is length times width. The pool is 12 by 16. So I'm going to go ahead and do 12 times 16, which equals 192. Now I'm going to do the big rectangle. The area of the big rectangle. What is this distance right here? The whole distance. That entire distance is going to be 12 plus 8 plus 8. And some of you are like, hold up. I thought the deck was just 8 feet wide. You're absolutely right. However, from here to here is the pool. In agreement? And then from here to here is the deck. And then from here to here is also the deck. So I have pool plus deck, which equals, again, I'm going to use my calculator, 28. I'm going to do the same thing on the bottom. So I'm going to have 16, which is the pool, but then I have 8 feet of deck on this side and 8 feet of deck on this side. Do you see how this picture is helpful? So 16 plus 8 plus 8 is going to equal 32. So the big rectangle is going to be 28 times 32, which equals 896. Now what? Now I need to take the big rectangle and subtract out the pool, and that's going to give me all of this deck. So 896 minus 192 equals 704 square feet. What does that number represent? When I'm solving problems, I'm constantly asking myself that question. What does that number represent? Because I don't want to get lost in the weeds of my work. That number is the area of the deck of this pool. I'm trying to figure out, how much does the pool cost? Or the deck. How much does the deck cost? How am I going to finish this problem? Multiply 704 by $6.50, and that will give us the cost of the deck. Because if there's 704 square feet and each square foot costs $6.50, then if I multiply the two together, I'll get the total cost of the deck. So when I multiply 704 times $6.50, I get $4,576, which is C. Let's go ahead and go into problem number 3. Ooh, this one was specifically requested. This one was specifically requested. The graph f of x equals the absolute value of x minus 4 plus 3 is shifted 3 units up and 2 units to the left to create the g of x function. What is the equation of g of x? All right. I just love these kinds of problems. All right. So here's what I don't want you to do on this problem. I don't want you to assume that this is the answer. Or that this is the answer. And that is going to be the first response, the quick response out of most of my 7 through 12, 6 through 12 people. Why? Because that would be the shift of f of x equals the absolute value of x. But they shifted this graph, not the parent function. They shifted this graph, not the parent function. So let's take a look at what this all actually means. If I were to graph the parent function, if you are taking the high school and even really the middle school test, knowing the parent functions, which is just the OG of function graphs, is going to help you tremendously. The parent function of absolute value looks like this. A V-shaped graph centered around the origin where each of the straight lines has a slope of 1 and -1. Now, when I shift that graph 3 units up and 2 units to the left, it's going to land here. But that is not the graph that they asked us for. They said that the graph of this function is shifted. So what do we know about transitions of functions? What do we know about transformations of functions? We know that in f of x equals x minus h plus k, no matter what the function is, absolute value, cubic, square, whatever, where this is your vertex, that the k piece of this is the vertical shift up or down, and that the h piece is the horizontal shift left or right. Now, the k follows suit with the correct sign. A positive k means we're going up. A negative k means we're going down. However, a positive h means we're going left, and a negative h means we're going right, which is opposite of what our brains would typically tell us. So this function is going to be 1, 2, 3, 1, 2, 3, 4, centered right here. And you say, why? Because it went up 3 and it went right 4. Now, if I shift that graph 3 units up, I'm going to go 1, 2, 3 right here, and 2 units to the left. I'm going to land right here. Well, which one of these graphs or equations can I eliminate pretty quickly? I can eliminate A and D pretty quickly because I went 3 units up from 3. Like, this was my starting place. So if I started at 3 and I went up 3 more, I need to land at 6. But if I went 2 units to the left, I got closer to the origin because I was on the right side of the origin, which means if I started at 4 and I went 2 units to the left, I'm going to land at 2, which gives me C. Now, if you're not a visual person and you're a very algebraic thinker, how could you solve this problem? Well, if I know I'm shifting from here up and left, I could just take the K, which is 3, and if I'm going up, I'm going to add more to that. So I could add 3, which is going to give me 6. Right there, I've already eliminated A and C, and if I had no more time, like my time was up, I could at least choose that one. Like, I could at least have a 50-50 shot between B and C, right? And then my H value right now is -4, which is really a +4, is it not? Because I'm in the positives, it's opposite of what we think. And if I'm going 2 units to the left, I'm going backwards, which means I could subtract 2, which is going to land me at 2, but we know it's going to be opposite, which gives us the x minus 2. So if you're an algebraic thinker, you could solve it like this. If you're a visual thinker, you could solve it like this and then conceptualize where you're landing if you don't have grid paper. That right there is transformations of graphs, and that would have worked with absolute value, with a quadratic with a cubic, like any graph that follows that vertex format is going to follow that patterning with your HK transformation. Let's go ahead and move on to the next problem. I did another transformation problem for us, so let's go ahead and look at it. The graph of f of x equals x squared minus 2x plus 2 is transformed, and the new graph is shown below. If the graph of the image below is g of x equals x plus 3 squared plus c, what is the difference of the c value in g of x and the c value of f of x? Now, this is a fun question. So, the graph of this image is, or this equation is transformed. And this is the new equation. And the graph of this image is this. What is the difference of the c value in g of x and the c value in f of x? Well, what do we know about vertex form in a quadratic? G of x equals x minus h squared plus k, where hk is the vertex. What I notice is that my vertex is at -3, -1. And they've already represented the -3 right here. So g of x equals, it did it again. All right, let's go ahead and reconnect. Welcome to Math Night, where the iPad just disconnects every once in a while. It's connecting. All right. Here we go. Okay, so they've already represented the 3 in the vertex form that they gave us. They said x plus 3. Why did they say x plus 3? Because remember, it's opposite of what we actually think that the sign would be for the x part or the h part. But then the k. If the vertex is -3, -1, the k value is going to be -1. So the question was, what is the difference of the c value in g of x and the c value in f of x? Well, c for g of x is going to equal -1. Now I need to find c for f of x. Hint, hint, it's not 2. This is in standard form. It is not in vertex form. Question of the day. How do I put a quadratic equation in vertex form from standard form? How do I put that in vertex form from standard form? Completing the square. Probably one of my least favorite things to do in mathematics. I don't know why. I just don't love completing the square. So I am going to take this, shrink it down, and move it so that I have enough space to complete the square. Complete the square. So f of x equals x squared minus 2x plus 2. To complete the square, I am trying to factor a piece of my quadratic so that I have a squared portion. So what I'm going to do is I'm going to take this chunk right here, and I'm going to do x squared minus 2x plus blank plus 2 minus blank. Now, sometimes you will see people teach completing the square by moving the 2 to the other side, and then you're adding blank and adding blank on both sides. That is not the most efficient way to complete the square when you're trying to put it in vertex form, because you don't want anything on the other side. So why did I add a blank and then subtract a blank? Because if I add 5 and subtract 5 at the same time, I'm theoretically adding nothing, because I don't want to change the core value of this equation. What I'm trying to do is just adjust the format. So it's almost like taking a cup of water and then putting it in the freezer and then taking it out of the freezer and then putting it in the freezer and then taking it out of the freezer. Am I changing how much liquid is inside this bottle? No, I'm just changing its state of matter. However, if I pour more water into it, now I don't have the same amount of water. If I just add 5 and then add 5, I've now changed the core value of this. But if I add 5 and subtract 5 at the same time, I'm not changing the core value of it. So I'm going to add a blank and subtract a blank all at the same time. What goes in that blank? B divided by 2 squared goes in both blanks, because whatever you add, you have to subtract. Or if you do it on both sides, you have to add and subtract, add and add on both sides. Hey, Monique, it's good to see you. It is good to be back. All right, so B divided by 2 squared. That's what you want to remember. B divided by 2 squared. What is my B value? -2. That is critical for you to know that it is a -2. So -2 divided by 2 squared. -2 divided by 2 squared. Now, what I've just done is create a perfect square trinomial. I have just created a perfect storm for this little guy right here. And what that means is I can now factor that to be x minus 1 and x minus 1, which equals x minus 1 squared. There is no need for you to do this step, because I'm going to give you a cheat. You can literally just write parentheses x minus blank squared, and that blank is b divided by 2. Which is why that -2 was so important, because -2 divided by 2 is 1. And now, what is -2 divided by 2? -1. What is -1 times -1? +1. But this right here is a subtraction symbol. So it is important for you to realize that because it's a subtraction symbol, this is +2 minus 1, because this whole thing produced a 1, and it's -1. If that whole thing produced a -1, then it would be minus -1, which would equal a +1. That was a whole lot of negatives and positives in one sentence. I hope it made sense. So I have x minus 1 squared plus 1. So the C value in f of x equals a +1. So what is the difference of the C value in g of x and the C value of f of x? If I do -1 minus 1, the difference is -2. Which is B. All right, let's move on to problem number 5. This one was specifically requested as well. Someone specifically asked for high school student error analysis. So let's go ahead and read through this problem. A teacher presented a problem to their students, and the student responses are below. Which of the following statements below are true? Select all that apply. A. Student A is incorrect. Student A did not distribute the negative correct. B. Student B is correct. They understand that I has a value of -1, which is why the -4 became a +4. C. Student C is incorrect. They did not finish evaluating the imaginary number. D. Student C is correct. They understand how to simplify expressions with imaginary numbers. All right, so here's how I always coach people on how to do error analysis. I encourage you to take the problem and solve it yourself, especially if you're confident with it. And then from there, evaluate the student errors. Because sometimes when we are looking at student work, it is difficult to identify their error because they make it look so convincing, right? So I know that if I'm subtracting this entire thing, I know that this needs to be distributed. So 5 plus 4i minus 8i minus 3. That right there is going to be one of the biggest mistakes we as adults make. So I'm sure a student probably made it. Then I'm going to do 5 minus 3, which is 2. And I'm going to do 4 minus 8, which is -4i. And that is my answer because I equals the square root of -1. I does not equal -1. So when I was reading those answer choices, I would have immediately crossed off B because I didn't need to do anything else. They understand that I has a value of -1. I does not have a value of -1. So I know that that's not going to be the answer, even if I don't do anything else. Now, again, I'm not going to look at student errors until I at least solve the problem so that I can better understand where the student is coming from. So now I'm looking at 2 minus 4i, which means that student C is the only one that is correct. So student C is incorrect is not correct because student C is correct. But student A is incorrect. So the answer or the question said select all that apply. So I'm going to also look at letter A just to see if the reasoning is correct. I'm not going to just choose an answer because student A is incorrect. Student A is incorrect. We know that, but I want to make sure that the reasoning is also correct. Student A did not distribute the negative correct. Well, let's go back and look. Did they distribute this negative all the way through? No. So this is also a true statement. Student A did not distribute the negative correct. So in this case, we have 2 correct answers. All right, we have time for one more problem. So let's go ahead and look at problem number 6. And while I'm solving this problem, I want you to think about What do you want to see me solve next week? I'm going to make my next week list right here. And I want you to tell me, what do you want me to solve next week? Do you want to see me solve a specific problem? Is there a certain concept that you want to see me solve? What are you looking for so that I can best serve you? So, problem number 6, and then we'll do our next week list. A local florist was contracted to make 1,500 bouquets for an event. 350 of the bouquets are primarily roses. 30% of the remaining bouquets are primarily lilies, and the rest are primarily greens. If the florist has already made 150 green bouquets, primarily greens, how many more green bouquets do they need to make? So we have a box of flowers, and it equals 1,500. And that 1,500 is cut into sections. We've got roses, we've got lilies, and we've got greens. And they all have to add up to what? 1,500. And they straight told us 350 are roses, which means what? The rest are lilies and greens. And it says 30% of the remaining bouquets are lilies and the rest are greens. And I like to always go for the biggest mistake. The biggest mistake people are going to make is that they're going to find 30% of 1,500, which is not correct, because it said 30% of the remaining, which means I need to do 1,500 minus 350 to find the remaining, and then do 30% of that. So 1,500 minus 350 is 1,150. So that means between lilies and greens, there are 1,150 bouquets. Now I'm going to do 30% of 1,150. How do I find 30% of 1,150? Convert this to a decimal and then multiply. Of means multiply. How do I convert that to a decimal? Everybody needs to understand this. Hop that decimal place 2 places to the left. So if I hop it, I end up with 0.3 times 1,150. 0.3 times 1,150 equals 345. That means 345 bouquets are lilies. The florist has already made 150 green bouquets. How many more green bouquets need to be made? How many green bouquets need to be made? Let's figure that out first. So we need to do 1,150 minus the lilies to get the greens. We were so close. So I'm literally just going to flip my screen around because it takes so long to share. So that equals 805 greens. If they've already made 150 greens, all I need to do is do 805 minus 150 to figure out how many greens need to be made, because they've already made some of them. which equals 655. All right, let's go to our next week's slide. What are you thinking? Now, obviously, if we don't end up with any next week topics, totally fine. Because trust me, I will come up with problems for next week. You don't have to worry about that. But if there's something specific that you want me to go over next week, let me know. Let me know in the comment box. I'm going to turn it back over to Dr. A. But let me know in the comment box what you want to see. I can already feel my voice. It is crazy. I have not had a voice for like 3 weeks. And it's finally been back for like 5 days. But I can already feel it like straining. So my voice is still not like super strong. Okay. Anyways, turning it back over to Dr. A. Let me know in the comments what you want to see from me next week. Marco, Monique, it was so good to see you. I will see you both next week. Have a wonderful week. Have a wonderful weekend, and I will see y'all later.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.